Good afternoon to doctor and my fellow friends. My name is Jaen. Our matrix is S72130. Now I will start with the acoustic sensors. What is acoustic sensor? Acoustic sensor is a device that converts a sound wave signal into an electrical signal. It usually measures the sound pressure or the displacement directly. So why is acoustic sensor so important? It can be classified into four categories, which industry and safety used for the fault detections to prevent the equipment failure and ensure the continuous operations. For the environmentals and ecologicals, it can monitoring of the noise pollutions and biodiversity. For the healthcare and diagnostic is non-invasive internal analysis of the physiological functions. For the security and surveillance, it can identify the traits for the rapid response so we when we are in danger we can know very quickly and do respond. For the application of acoustic sensor can be classified into six securities and surveillance like the gunshots detections and intruder detections and the perimeter security can be used to apply acoustic sensor. Furthermore, acoustic sensor also may be used for the parking assistance, active noise cancellations, or the detect potential hazard through the sound recognition. So when we parking in shopping mall, we can use the sensor to help us to find where is the vacant parking lots. Furthermore, it also can be used in medical devices like stethoscopes and can be integrated into smart home system to detect specific sounds like glass breaking. Acoustic sensors are utilized in the musical instruments like uh like audio audio recording device and various audio technologies. It also can be used in the robotic which is sound localizations. This can be classified into three fundamental principles like piezoelectric effect, which is a certain materials like quartz, piezoelectric ceramic generates an electric charge when mechanically stressed by the sound pressures. It can generate its own electrical signals, so it does not require any external power source to functions. It's very durable and can be handled with high sound pressure levels. So for the capacitive sensing, sound wave can vibrate a thin conductive diaphragm which acts as a plate of capacitors. These vibrations can change the capacitance which is converted into a voltage. This principle is difference with the piezoelectric effect which does not require an external power. For this, it requires external power source to charge the capacitor and run the internal circuitry. It also can be engineered to be very sensitive with a flat frequency response, making it an ideal for high quality audios. It can be used in smartphone, laptops, and for the piezoresistive effect, normally we are used in the automobiles and commercial device to convert electrical energies to mechanical energies and vice versa. The electrical resistance of a material will change when it is mechanically shrinks by the sounds. So according to Cadian's results, the piezoresistive transducers are valued for their high sensitivities and ability to be fabricated directly onto the silicon chips. Now I will continue with the type of sensor based on the operating principles. There are five types. Piezoelectric acoustic sensors can convert the sound pressures into the electrical voltage using the piezoelectric materials. The common application used are ultrasonic sensor and hydrophones. The capacitive acoustic sensor is detect the diaphragm movement change capacitance between two plates. So the common application are condenser, microphone, and sound level meters. For the optical acoustic sensors can use to detect the sound induced change in light phase or light intensity. It can be used in structural health monitoring and underwater acoustic. For the magnetostrictive acoustic sensors, it can change the shapes under the magnetic field from the sound wave. It can be used in the ultrasonic transducers and precision sensors. For the MEMS acoustic sensors, it can be used to miniaturize the capacitive or the piezoelectric sensors on silicon chips. So normally it will be integrated into the smartphone or IoT device. Acoustic sensor by the medium of detection have trace, which is air-coupled acoustic sensors through the medium air. Working principle is can detect the sound wave traveling through air using the piezoelectric capacitive or MEMS principles. The common applications are noise monitoring, space recognitions, and others. For the water coupled acoustic sensor, which known as hydrophone, which require a medium of water to pass through. It can detect the underwater sound wave pressures will change in the liquid mediums. So for the common application is sonar system underwater communications. Next, solid coupled acoustic sensors will require a medium which is solid to pass through. It can use to measure the vibrations of the stress wave propagating through the solid structures. It commonly will use in the structural health monitoring and non-destructive testing. Last is based on the frequency range. So it also classified into three types. Infrasonic sensor with less than 20 Hz. It will detect very low frequency sound wave, often below human hearing range, and it is used it will be used as the earthquake detections, explosion monitoring. For the audible range sensors, is between the frequency 20 Hz to 20 kHz. It can detect the sound within the human hearing range. Normally will be in music recording, environmental noise monitoring. Last one is the ultrasonic sensor, which is very high frequency, which bigger than 20 kHz. It can use for the detections high frequency sound wave beyond the human hearing. Normally people invented the distance measurement medical imaging for this sensor. There are a few advantages and disadvantages of acoustic sensor. The advantages are high sensitivity and precision the instrument and non-contact detection, which means we don't have to contact the the sensor with the things at a contact point. Only can get the result. We can get the result with a long distance, even that it does not touch the surface of the things. It also can work across the air, waters, and solids. It is compact and durable, for example, MEMS. For these advantages, it can be affected by environmental noise. So we have to make sure that we do not have much noise before we use it, and limited range in some medias. It may require calibrations before use to get an accuracies and precision result. It's expensive for the opticals or fiber types. For the future trends of innovations is can be integrated with the IoTs and AIs for the smart monitoring, flexibles and variable acoustic sensors for the health and environmental tracking, use of the nanomaterials to increase the sensitivities, energy efficient MEMS sensors can be used for the portable device, and also the development of underwater sensors network for marine observation. As we know, in marine we cannot detect the things easily, so we have to use these things to help us detect easily, and this is my reference. Thank you for your listening and attention. Thank you.